Welcome to Paul's Passive House. Now that the pour is finished and dried, I'm going to need to do some more work to prep it for insulation and for sealing. As you can see, I have to take off these little pegs that I glued to the floor, and luckily they come off really easily. Next, I have to take off this foam backer, and sadly, it's not as easy as you might think. When you pour the leveler down, it actually seals to the backer and hardens to it, making it rather difficult to get off. One thing you'll notice is that I put up plastic. Now, when you're pouring floor leveler, you need to cover the windows because the leveler itself is responsive to UV light. The parts of the leveler that are exposed to UV light are going to dry differently than the parts that aren't. So you want to make sure you cover the windows when you do a floor pour. The other reason that I have plastic up is because I've already installed the mineral wool, and I'm trying to keep the dust levels down in my house. Now that the foam backer is uninstalled, let's take a look at the edge. You'll notice here that the edge is very clean. This product is fantastic. The floor leveler really works well. And you can see that other than a few little ripples and wrinkles here and there, it's pretty seamless. And there was also plenty of leveler for this corner here, where that raised area was, and I had to grind that down. Now it's time to vacuum and clean up, which is Bronson's cue to exit. He does not like the vacuum, so he's going to get out of there. Once the floor is clean, it's time for me to seal the edges. I'm going to be using this Dynaflex 230 product. It's a great product made by DAP. Sealing up this sill plate edge where it meets the floor is going to ensure that I don't get any heat gain or loss from outside air. It's going to help to further provide me with an air barrier, and it's also going to keep out any insects. And really, ultimately, that's one of the key benefits here is my house, after doing this work, has nearly no insects in it. I still get little bugs from time to time, but that's because I don't have good windows and my doors aren't currently sealed up perfectly. So once I get better windows and better doors, I won't have any bugs in the house at all. And I'm really looking forward to that. But I have to tell you, after sealing up the walls and sealing up everything and doing all this work, completing all this work, I have almost no bugs at all infiltrating into my house. So after I lay the bead of caulk down, I'm going to push it into place with my finger. This doesn't have to be beautiful. It's not finish work, so it can be a little sloppy, and you'll notice that it is. But pushing this DAP product into the gaps is important aspect of it. I want good connection with the wood and the floor leveler. Taking one last look here, you can see that my sill plate is now perfectly sealed. This is really future-proofing my house from future infestations. Here's the first room that I poured, and as you can see, the floor came out pretty good. Now, this corner here is completely sealed up, no more radon, and it's a pretty clean product. If we pause here for a second, you'll see that I had to grind down this edge. There was a bump right there where it was flat, and then after the bump, it sloped towards the corner of the room. Now, the floor leveler didn't fully resolve that because I didn't pour enough of it. In fact, I would have had to pour almost 2 inches of it to make this floor perfectly flat. And so I didn't do that. Instead, I opted to make it flat enough. As long as it's not bowed in the middle in multiple directions, a floor like this can be flat without being perfectly level. And that's an important distinction to make. Now, this bump had to be no more than 1/8 of an inch for me to be able to put down like vinyl plank or any kind of wood flooring. And I haven't actually decided what kind of flooring I'm going to get, but I did have to grind down this bump because when I poured it initially, it was over 1/8 of an inch that bump. But if you take a floor level and you go from end to end in this room, it'll be perfectly level in one direction, and then the direction where that bump is will show that it isn't perfectly level, but it is perfectly flat. And that's very important. This room still slopes towards that corner, but it only does so in one direction, not two. And so the floor is flat. It's just, now, one of my concerns is that I still have a crack behind this tub, and I'm worried that that crack is letting in radon. Now, I did a test and I didn't notice any elevated levels of radon coming from either end of this tub. Here's where I tested for radon. And as you can see behind that tub, there is a nice big gap between the floor and the foundation. Now, I have to test this further to see if my radon mitigation is working to suck air through that crack. Here is, if we pause here for a second, here's the hole that I dug into my foundation and under my floor to install the radon mitigation. You can see there that there is a wood piece. That was an open hole in the concrete that went under my floor. I dug it out with a post hole digger so that it was about 2 feet deep. Then I put 3-inch PVC pipe down into that hole. I drilled some holes in the pipe so that it would suck from all directions, and I brought the pipe up to this 90 degrees, and then it runs out into my garage. Once I got it all set up, I put this piece of wood down, and as you can see around the pipe, there's some sealer. Now, that's a temporary sealer. I'm doing just a preliminary seal and tests to see and ensure that it's actually getting all the radon out. But I sealed up that pipe, and then I sealed up the edges around this piece of wood. Following that pipe out into my garage, you can see that it takes another 90-degree turn and then goes up into the roof. Now, that fan runs all the time and is pumping radon out of my roof and through a pipe right there, through that vent. Now, that vent is at least 10 feet away from my windows and doors. That's code. It has to be 10 feet away from any windows or doors because the air that's coming out of that pipe is radon rich, and it could be really high levels of radon because it's pumping it out of the ground. Now, I know this camera angle doesn't make it look like it's really far away from this door, but if you measure with a tape, you could see that it's more than 10 feet away from this door, and it's more than 10 feet away from any windows. Plus, the wind, generally speaking, is blowing this radon over the top of my roof and into the front yard. So I'm not getting any radon infiltration back into the house. So I'm now going to go back into that space where the crack was behind the tub. I'm going to open up this wall, and I'm going to test with that fan on to see if that crack is open or if it's sealed. So if we take a look behind this wall, we can see that crack is very prominent. If you look into the crack, you can see there's all kinds of evidence of rodents and bugs and everything else. And ultimately, I want to seal that up the best I can. To test the crack and see if I'm getting suction from my radon fan, I'm going to use a smoke pen. Now, if I hold the smoke pen above that crack, if there's suction, it should suck that smoke back into the crack. It's a little hard to see here, but once I turn the light, as you can see with the light on the smoke, that it is not being sucked into that crack. It's billowing upwards. So I'm going to grab some power grab and glue some scrap drywall that I had to seal up that compartment. Now, everything behind the tub, once I seal all this up, all these seams and spaces and gaps, once I seal all that up, that space behind the tub will be airtight. And that's my goal. I want to make that as airtight as possible. So I've made my way back into the attic, and I'm going to show you the design that I went with. First off, I put up radiant barrier. As you can see, all that foil is radiant barrier. Now, it's important to remember that I have a vented attic, but the only part of my attic that I want vented is right below the roof deck. So that radiant barrier covers the roof deck and leaves a space, a 3.5-inch gap between that radiant barrier and the bottom of my roof. That space is vented. It's vented at the top. I have a roof vent that goes all along the top of my roof, and then some of my soffit is vented as well to add airflow. Now, this was no easy task to decide to do it like this. I wanted to maintain a vented attic and close off this attic space, make it airtight, and have a thermal barrier, and this is what I decided to do. Now, this is probably not the best way to do this, but this is what I got. So initially, this is the configuration that I decided to start with. What you're looking at right now is 2 pieces of 3.5-inch polyiso stacked on top of each other, cut so that they'll fit between the attic joists. Above that is a 3.5-inch piece of polyiso screwed to the bottom of the roof deck. Now that polyiso, originally, I was going to run all the way up the roof deck, and I was going to fill the gap with that piece that you see right there. That's how I was going to bridge that gap originally. I was going to take a piece of polyiso and I was just going to screw it and then glue it to itself. So it was going to bump down. Now that's not how I decided to do it when it was all said and done. That actually ended up being too labor intensive. So as you can see, the design is starting to come together. Above the attic joists, I've cut pieces 2 foot by 4 foot that I can install under the roof deck. That was the largest piece I could fit in this tight space. Those pieces are going to meet with the pieces that I cut to fit in the ceiling joists. Those ceiling joist pieces, in turn, are going to meet with the pieces that I install on the walls below. Above that, I was able to fit pieces that were cut to 2 foot by 8 foot and install those to the roof deck. 2 feet at a time, I made my way towards the top of the roof. If you'll notice right here, you can see that 6-inch gap that I cut out of the drywall. That's where the polyiso that I install on the exterior walls is going to meet with the polyiso I install here in the ceiling joists. Here you see a good example, some good footage of exactly how this was all going to come together. Now I was just going to repeat this whole process all the way across underneath the roof deck. Here we see that south wall. Now I was using this fire resistant or fire block spray foam that you buy, and I was putting that between the sheets of polyiso to seal it up and to make it airtight. This was a test. Again, most of the work that I did up here, I had to design and test myself. Jumping ahead, you can see that I've installed all the polyiso insulation from one end of the roof up to the top, across the top, and down the other side. If you take a look above the polyiso, you can see that I still have a gap. If you look at the top of the roof there, that's where my roof vent is. And I've bridged this gap with the polyiso going horizontally. Now on top of that, I put more reflective barrier. But this allows for me to have a vented attic and a sealed attic at the same time. This is sort of a hybrid design. Getting a closer look at the underside of the roof deck, all of the 2x4 and 2x8 pieces are installed. All of the fire block spray foam has been installed, and you can even get a good look at how I connected all these pieces. Taking a closer look, you get to see here now, I installed polyiso in the ceiling joists. In some areas, I needed to do 2 layers of polyiso in the ceiling joists. And you see that on the left. And in some areas, I only needed 1 layer. Now, that was just because of a framing issue in my roof. But all of those layers then now connect with the fire block spray foam. It's all airtight. It's all sealed. And that provides me with my continuous thermal barrier. This polyiso connects to polyiso that goes on my walls downstairs. It goes all the way up to the rooftop and all the way over to the other side to connect to the other wall. I've encapsulated my house in a 3.5-inch thermally sound layer of polyiso. As I move through the attic, you can see that I've started to install the fiberglass batting. Now, I prefer batting because it is modular. You can take it out, you can put it in, you can move it around. And while it looks like it's pretty tightly packed, it's actually sort of puffed out. Stopping to take a look here, you can see that I've got multiple layers of fiberglass going all the way out to where the roof meets the wall. So there's 2 layers at the smallest point, which expands to 3 layers, which goes to 5 and 7 layers. And at its tallest here, I've got 8 layers. Now, each layer is 3.5-inch thick. Each 3.5-inch thick is an R11. So that's an R88 right there. I'm going to continue this process to fill the entire attic all the way to the top to maximize the R value of my roof. Now, one of the reasons that I did this to really maximize my roof R value and make it airtight was, of course, I'm trying to meet the passive house standard, but I have a very serious and very difficult problem to solve in that my floors are concrete on grade and I can't insulate them properly. I'm not going to be able to get an R10 or an R20 or anything like that on my floors. About the most I can get is an R7, and that's only in part of the house. So I had to overcompensate in the attic, getting it up to well over 100, R100, in order to meet that passive house standard. So now I'm completely out of the attic, and you get to take a look at my HVAC design. It's not complete, it's not installed in its entirety, but I have installed on both ends the fiberglass batting, and you see here there's my main trunk on the right there. That's 12-inch round HVAC pipe. That's going to distribute air to my house. On the left, there's a 6-inch pipe, and that is for my HRV. That's a heat recovery ventilator. That's going to bring in fresh, ventilated, hospital quality air to the entire house, and it's also going to exhaust stale air to the outside. We get a quick look at where the trunk tees off and goes into my addition, and you can see where the return line comes from the addition and goes back towards the garage where I'm going to have a utility room. All that had to be custom cut, all the polyiso, and fit and sealed with the foam. Looking back towards the south wall, you see where my HVAC splits off into 2. And you see where the HRV, the black pipe, splits off into 2. Now, all of this had to be sealed. You can see I used duct sealer. That duct sealer was also used anywhere else I needed to seal things. HVAC duct sealer, the kind that you paint on, is incredibly useful. If you'd like a free energy efficiency consultation, please email me at paulspassivehouse@gmail.com.